Hi guys, welcome to 311 part 2 where we're still looking at secant, cosecant, and cotangent. So in the last video we talked about, and I'm actually going to go down to the bottom first, the relationships that exist with our previous trig functions that we knew. So remember, cosecant is the reciprocal of sine. So that's the same as 1 over sine of theta. If you're looking at it in a triangle, remember sine is opposite over hypotenuse. So you could also write this as hypotenuse over opposite. Secant is the reciprocal of cosine, so you could also write that as hypotenuse over adjacent in terms of a triangle. And then cotangent is the reciprocal of tangent. And again, that would be adjacent over opposite. Another way to write tangent and cotangent, well, we know tangent is sine over cosine. So that means that cotangent is cosine over sine. So let's look at a few examples with the unit circle, okay? So this one says secant of 13 pi over 3. Well, we know that that's too big, so you could keep going around the circle, or you could subtract 2 pi. I'm going to subtract 2 pi because I know that's a full circle. So when I subtract that, I get 7 pi over 3, which is still too big, so I'm going to subtract 2 pi again. And I end up getting pi over 3. So this would be equivalent to finding secant of pi over 3. All right, so if I go to pi over 3 on my unit circle, it's 1/2 comma square root of 3 over 2. Secant is the reciprocal of cosine. Well, cosine of pi over 3 is 1/2. So the secant is the reciprocal of that, so that would just be 2. All right, let's do another one. Let's do cotangent of 9 pi over 2. So that's too big, obviously, so I could subtract 4 pi over 2 to get 5 pi over 2. Subtract 2 pi again, and I get pi over 2. So at pi over 2, my coordinate is 0, 1. Tangent there is sine over cosine, so 1 over 0. Tangent at pi over 2 is undefined, but cotangent, we said down here, is cosine over sine. So that would be 0 divided by 1, which is just 0. Let's do one more. Let's look at D. Well, that's too small, so I'm going to add 2 pi. So I'm going to add 12 pi over 6 to get negative 5 pi over 6. I'm going to add 2 pi again so that I get it as a positive angle, and I get 7 pi over 6. So 7 pi over 6 is right here on my unit circle. It's the big X, little y, and my coordinates here look like this. Secant, again, is the reciprocal of cosine. Cosine at that angle is this negative root 3 over 2. So I'm going to flip that, and I get 2 over negative square root 3. If you did want to rationalize that, I would multiply the top and the bottom by root 3, and I would get 2 square root 3 over 3, and then don't forget the negative on either the top or the bottom. So a lot of what we've been doing with unit circle, but you should also now be able to, if I ask you cosecant, secant, or cotangent of an angle, it's just the reciprocal of one thing that we've already found. So let's look at a couple examples with triangles. So we have the point negative 2, 5. So that's going to be in quadrant 2, negative 2 as my x, 5 as my y. And I want to find all 6 trig functions. So to find the hypotenuse, I need to use a squared plus b squared equals c squared. And I get 4 plus 25, so c will equal the square root of 29. All right, so if I want, remember theta is always at the origin. So if I want sine of theta, I'm not going to rationalize these, okay? So opposite over hypotenuse, which then means cosecant of theta is the reciprocal. That would be square root of 29 over 5. Cosine of theta is negative 2 over square root of 29. I would pause it at this point and try the other 3. Secant of theta is square root of 29 over negative 2. Tangent is opposite over adjacent, so that would be 5 over negative 2, which makes cotangent negative 2 over 5. So all things that we've done before, just flipping them around. All right, let's do one more. Like this, so they give you that sine of theta is this. Well, if sine and cosine are both positive, that means I have to be in quadrant 1. I know this is opposite, and this is hypotenuse, and this is adjacent, and this is hypotenuse. So that means my hypotenuse is 13. My opposite will be 2 square root 13, and my adjacent will be 3 square root 13. All right, so let's go ahead and find tangent of theta. It's opposite over adjacent. We do need to simplify this. That's not the same as rationalizing. I do see that this and this are the same, so I just get 2/3, which means cotangent of theta is going to be the reciprocal of that, which is 3/2. All right, and then we have cosecant of theta. Okay, that is either the reciprocal of sine, or you can think about it as hypotenuse over opposite. So that would be 13 over 2 square root 13. And then secant is the reciprocal of cosine, or hypotenuse over adjacent. And that's what you get for that. All right, let's look at if I was going to write equations from a graph. So you could write two different equations for this. I mean, you could actually write many different equations, but I see right here that if I were to draw in kind of the sine or cosine function, that green function would be a negative cosine because it starts at a minimum. So I know that secant is the reciprocal of cosine. So I could just write it straight away as negative secant of x, because that would be the reciprocal of negative cosine of x. Alternatively, I could write it as a phase shift, okay? Because I know that if I shift sine left or right, then that's what that would happen there. So this one, if I normally start at the origin, but I've gone right by pi over 2, because remember sine of x would pass through the midline. So I could say I could also write it, this green function, as a sine that's gone right by pi over 2. Well, then if I want to write the kind of baby parabolas, the reciprocal of that, well, the reciprocal of sine is cosecant. So it's just going to be cosecant. And then remember, right pi over 2 would be x minus pi over 2 in parentheses. Okay. All right, so let's look at one more where we graph it ourselves. We're going to go down to this last one that says transformations method. So the vertical, first we're going to find the vertical shift. That's going to happen on the outside. That's y equals -1, which will correspond to the midline. So I'm going to go ahead and plot that out. The phase shift here is after we factor out the b value. So just like we did with sine and cosine, still have to factor out that 2. And you can see they did it for you there, and you go right by pi over 2. The b value here is going to be 2, because that is what's right here. And then if I wanted to find the period, remember secant has a period of 2 pi, just like cosine does. So 2 pi over 2 means the period will be pi. So the reciprocal function of this would be y equals negative cosine of 2x minus pi over 2 minus 1. So the easiest way to do this is to kind of graph that function first. Because it's negative cosine, it'll start at a minimum with an amplitude of 1. Okay, so that means that it will start down here at -2. And then the period here is pi, so that means at pi, it'll get back down to that minimum there. Okay, well, let's think about what we know about cosine. In between the two minimums is going to be a maximum. So that means I will have a maximum at pi over 2, 0. Okay, it's been shifted down 1, remember, that's what this -1 does. And that means in between those points, it'll pass through this midline here. So I'm just going to go ahead and plot a few other points. So it's going to look something like this. That is my negative cosine 2x minus pi over 2 minus 1. Okay. All right, so then we can draw in kind of where does it equal 0? Where are asymptotes? Okay, so first, let's go look at this on Desmos, because I think sometimes that's helpful to kind of see what's going on. So if I first graph y equals negative cosine of 2x minus pi over 2 minus 1, oops, not equals 1, minus 1. Okay, so you can see though, we still have to move it this, we still have to do the phase shift, which has gone right by pi over 2. So instead of the minimum being at 0, we need to go right by pi over 2. So that right there is just my normal cosine function, but then I still need to shift it right. So if you want to use a second color, sometimes that's helpful. Okay. All right, so if I shift this right by pi over 2 because of that phase shift, this would go here, this would go here, this would go here. This would still be at the midline, still be at the midline. This would now be at a maximum. So essentially all the maxes are going to become mins, okay? And now from this point, I can draw in my vertical asymptotes. Now, think about the secant function will have those vertical asymptotes wherever cosine equals 0, and then it will shift down 1. So wherever it intercepts with the midline, I know you're thinking that's actually -1, but that shift happens after the fact. So everywhere that it hits that midline at -1, you're going to have an asymptote. And I highly doubt that they will ask you to graph something like this on the AP exam, nor will I on your test, but this is very possibly a multiple choice question of being able to see the transformations. So then the last step is to draw in your little baby parabolas. And you can see it will look something like this. So big ideas: identify your transformations, graph the parent function, do any phase shifts, and then the reciprocal of that, draw in your asymptotes first, and then draw in your parabolas from there. So just real quick as a reminder, the range on this function, because sometimes people mess that up, would be from -infinity, and then it would stop at -2, including -2. That point is included. And then it starts up again at 0 until infinity. So just be aware, make sure you can find domain and range of these. Domain would be everything except for the asymptotes, but most of the time what I in the AP exam will ask you to do are things like knowing your unit circle of these values. So that's all for 311. Have a great rest of your day.